Hey everybody, Mr. Bowman here. This video is for the right angle triangle internal. It's for the year 11 math course. And we're going to focus on the achieve stuff first. And what I'm actually going to do is I'm going to ignore the question-y part of the question, which is a bit weird for an internal. And I'm just going to focus on part 1 of the internal, because achieved is all about showing the right skills. The stuff above is relevant for the merit and excellent stuff, and we're going to get through that in the next part of the video, but let's just look at the skills. So the question here was simply determine the height of the rugby posts, and we just popped out onto our school field. So if you're at a different school, you could do this. And we just went out, did some measurements, and we tried to estimate how tall our rugby posts were. So before I made this video, what happened is I found a random spot on the field, and then I would have stood on that spot, and from that spot I would have taken I did 2 measurements. What I did is I measured exactly how far away from the rugby posts I was, and I actually ended up being 10 meters away. And then after that I used the angle measurer, and I figured out what angle it was from my eye level. That's why I started the line at my head to the rugby posts. And I'm just going to draw another line here, because that angle was actually measured from my eye level, not from the ground. So if I drew the triangle connecting here, that wouldn't exactly be correct because of my eye level. And that angle I measured to be 36 degrees. The other thing I measured, I just knew how tall I was. So I'm 180 something centimeters tall, so my eye level was about 1.8 meters because it's slightly shorter than me. So using all of these measurements, I'm going to show a few right angle triangle skills with the ultimate goal of estimating how tall I was, or how tall the rugby posts were. So the first thing you need to do this internal is, away from any diagram, you'd probably want to look to sketch and draw out a diagram based on what we did through the video. So R1, and it doesn't have to be the scale, we're going to have a right angle triangle, and that triangle represents kind of this area of the diagram. And then underneath that, you'll see underneath that, we've got a rectangle. So we've got a rectangle down here. So you can see how the triangle matches that, rectangle matches that. And now that we've got the diagram sorted out, we're just going to put in some angles, put in the measurements that we know. So we knew this angle here was 36 degrees. And we know this is a right angle because the ground, and there's another right angle there, but the top one there, the ground would meet the rugby posts roughly at a right angle, unless you've had an absolute nightmare. I knew that this here was 1.8 because that represented my eye level, so slightly less than how tall I was. And I knew that this side under here was 10 meters because I measured that directly, and I knew that side up there was the exact same as that 10 meter side. So that's the first thing I'm looking to do, just looking to do a rough sketch. So the second thing I'm looking to do is I can use trigonometry to find out I'm going to call it y, shall I? The y side of the triangle, which represents from my eye level to the top of the triangle. So I'm going to maybe write that down. So eye level to top of triangle, which is actually top of the rugby posts. And I do want to note this little communication element is, I think, an important thing to do for achieve, just so the marker knows what you're trying to calculate. So we're going to draw a little sketch. I always redraw my triangles. You'll get annoyed by this during the video, but just something I do. It's a strategy I use because I find if I don't do this, I tend to make little math errors. And my right angle. So step number 1, label the sides of my triangle. So there's my hypotenuse, there's my opposite, and there's my adjacent. Step number 2, I'm going to cross out the side of the triangle that I don't care about. And that leaves me with the O and the A side of the triangle. And that tells you tan. So we've got tan angle equals O over A. Following that, we're going to substitute. So my angle is 36. So let's take that away. So we've got tan 36 is equal to O, which was the Y side of the triangle. So we're going to put the Y on the top. And then 10, which was the A side of the triangle. So I'm going to scoot on this way. So that means Y will be equal to 10. So because the Y is on the top, I'm going to multiply my other two parts. So 10 times tan 36. And at this stage here, I'm going to grab out my calculator. So Y equals 7.27 meters. And that was a 2dp rounding. So common question I get, sir, what should I round to? My advice for rounding is always be more accurate than the information that you're given. So we can see that 1.8 was the information we were given in the question. So I've just added on an extra decimal point than the information that I've been given. Okay, so step number 2 done. So what I now know, if I edit my triangle, so that blue part up the top there, I now know this bit here is going to be 7.27 meters tall. So because I've got this side of the triangle here, and I've got the now up and down side of the triangle, even though the question hasn't asked us this, I'm just trying to use skills. I'm going to, maybe we'll call this X. I'm going to calculate this third side of the triangle. And that's the direct distance from my eyesight to the top of it. So that's from me to the top of the rugby post. So slightly different to the other one. So yeah, let's give that a go. So we're going to call that X. So number 3. So we're going to use, I'm going to call it PT for Pythagoras' theory. We're going direct from eyes to rugby posts. I should say the top of the rugby post, isn't it? Okay, so as always, I'm going to draw out my little triangle again, because I just make math errors if I don't do this. So we've got 7.27 along this side of the triangle. We had 10 down the bottom of the triangle, and I called that X there. So my first step, labeling my sides, a little bit different. Opposite to the right angle is the hypotenuse, but that's C for Pythagoras' theory. And the other two, A and B, it doesn't matter which way around the other two are. So I'm going to jot down my formula. A squared plus B squared equals C squared. I'm now going to substitute. So my A side of the triangle is 10. So that A squared becomes 10 squared. The B side of my triangle was the number we calculated earlier. So that's 7.27. And that's squared. And then C squared is going to become X squared. So that there will be equal to X squared. At this stage here, you're going to grab out your calculator. You're just going to see what 10 squared plus 7.27 squared is. So plugging that all into the calculator, I get 152.8529. That there is equal to X squared. So X will be equal to the square root of that number I just said, 152.8529. And when I put that into my calculator, I'm getting 12.36 meters. And that there had a 2 decimal point rounding. So if you're able to get up to this point, that there is enough for achieved. Before I move on to the merit and excellence element, which is task 2, I just want to recap the skills you needed to show me to get achieved. So skill number 1 was up the top there. You needed to go out and do some physical measurements in relation to the diagram. After that, a sketch converting the real world scenario into a mathematical sketch is really important. The next one is communication of what you're calculating. So those are the 3 kind of initial skills you need to do. Following that, you need to show me 2 kind of mathematical skills in relation to right angle triangles. So I showed how to use trigonometry to find the side of a triangle. And finally, I used Pythagoras' theory to find the side of a triangle as well. If you wanted to do an extra skill, the angle up the top of my triangle here, maybe we call that Z. We could use inverse trigonometry to calculate that angle there. The very final thing we should look at doing is we should look at wrapping up our conclusion. We haven't actually answered the question yet. How tall is are the rugby posts? So if you go back to our diagram, we know that this measurement here was 7.27, and we knew this measurement here was 1.8. So if we add those two numbers together, we're going to get the total. And in this case, that total is 9.07. So our conclusion, the rugby posts are 9.07 meters tall. So that wraps up the achieve section. Hopefully you've seen what we've done. We've got those 5 points in green that I've highlighted, and we've stated our conclusion. Following this, we're going to move on to the excellence stuff. And I've got some key information here already, just to help me remember them, because I kept on forgetting about the 2/3 thing there. But task 1 was completed. That was the achieve stuff. Now task 2 and the information above are all relevant for merit and excellence. And let's run through the question together. So for Ag Day 2024, organisers want to attach, basically they want to attach a large triangular shade to keep the livestock out of the sun. So these are rugby posts, probably the bars in there somewhere. And what they're going to do is they're physically going to attach this triangular shade to one of the posts. And that'll be supported by these poles kind of over here. So the sail will be attached 2/3 the way up the rugby post. That's what this measurement is. And then don't forget, in the previous question, we found out that the rugby post was 9.07 meters tall. The support poles, which are these poles here, they're all 2 meters, it says. So 2 meters, 2 meters, and 2 meters. They are 25 meters apart. So I'm guessing what that means is the distance from here to here is going to be 25 meters. And then finally, they're 10 meters away from the line where the rugby posts are. So that means the distance on this side here is going to be 10 meters. So we've got a whole heap of information, including the number we calculated in task 1, to go ahead and try to answer whatever it is we've been asked about. So Ag Day organisers have a budget of $3,000, and they've been quoted $27.50 per meter squared of area. So that probably means we're going to be looking to calculate the area of this shade, so triangular area, plus $200 per pole. So those are the support poles kind of down there. So I guess our goal is, well, we need to find the area of the shade, and once we've got the area, we can use the $27.50 to calculate the cost of the shade, and then plus $400 for the cost of the poles. So that's what I'm thinking of. So the first thing we want to do, again, just like we did for the achieve section, we do want to sketch. So we do want to draw out the triangles from the information we've got. And the first thing that I'm looking to do is just think about what I'm doing. So the triangular shade that we've got here, we know that the base is going to be 25 meters. And what we're looking to do here is we need to find the height of this shade. And if we do 1/2 of base times height, we've got the area. So area is equal to 1/2 of base times height. So we're just missing that height number. So that's where the other diagram comes into play. So that height measurement is actually going to be the same. If I draw the rugby post, and then that's where they attach it. Or let's draw that line again. That wasn't the best line in the world. And then that's the pole. So we know that the total height is 9.07 meters, and we know that the height from where it will be attached is going to be 2/3 of that. So 2/3 of that number is 6.04. So 6.04. Forgive, that was rounded to 2 decimal points, which means, and this diagram is going to get a bit messy, that means this number here, and that's because the poles, don't forget, are 2 meters tall. That means that number there is going to be 4.04 meters tall. So you can kind of see the triangle in here, 4.04 meters tall. I know the bottom of my triangle is 10 because we already had that information 10 meters away from the rugby posts. So that means I can go ahead and calculate this diagonal side of the triangle if I wanted to. And I really like the diagonal side because that there is the same length as the height of the triangle. So if I find x, I can switch the value for x over to h. I can then find the area of my triangle afterwards. So this is a bit messy one. This is where the insight or the excellence part of the question comes from. It's all about being able to see the different measurements between the diagrams and making some connections. So that's kind of what I'm aiming to do. So I guess step number 2, let's calculate x, which is the height of the triangle. I'm just going to put a little triangle there, feeling a bit lazy. So I'm going to redo my sketch because I make math errors when I don't do this. So I knew that this side of the triangle was 4.04, I knew the bottom was 10, and I knew that side of there, I called that x. So my Pythagoras' theory formula, a squared plus b squared is equal to c squared. Labeling my sides, so the hypotenuse is always c, a and b are the other ones. So my a squared is going to become 4.04 squared. So there you go, 4.04 squared. My b squared is equal to 10 squared. And then my c squared is going to become x squared. So that's my substitution phase of this question. I'm now going to get a calculator to figure out what 4.04 squared plus 10 squared is, which comes to, just looking at my calculator, 116.3216 will be equal to x squared. So that means x will be equal to the square root of that number we just calculated, 116.3216. And my calculator is telling me it is going to be 10.79 meters, and that there had a 2 decimal point rounding. So I've now got the height, and I should actually note that that's what h is equal to. H is equal to that same number as a result. So I've got the height. That means I can link this back to my area formula. Got the height, got the base. I can calculate the area of the shade. So that's going to be step number 3. And again, I'm going to communicate what I'm doing. Area of shade. So the area is equal to 1/2 times base times height. So I'm going to go 1/2 times 25, which is the base of my triangle up the top there. And then times the height, that's the number I just calculated, 10.75. I'm going to plug all of this into my calculator, and I get 134.875 meters squared. So I'm going to round that up because normally when you're dealing with materials, you probably need to have a little bit more for miscuts and maybe folding over some edges, that sort of stuff. So that's how big my shade is going to be. Now that I've got the area of the shade, number 4, I can calculate the cost of the shade. So our cost will be equal to the shade plus the 2 poles. So the cost of the shade will be that 135 times the cost per square meter, which we said was $27.50, 27.5, and we're going to add on $200 per poles, that's $400. And when I do all of those, I get $4,112.50. So I've now got the cost of it. So going back to the question, I've calculated the area, I've calculated the cost, and my last statement there is to figure out whether or not they're going to be in budget or not. So that'll be step number 5. So budget considerations. The Ag Day budget was $3,000. However, the proposed design is expected to cost $4,112.50. This is $1,112.50 over budget. Oh, not sure what happened there. Over budget. So what this means, so that's our conclusion, and that's enough. All of that combined is enough to kind of get you to that excellence mark. What that means is these Ag Day people, they're going to need to redesign their sale, rethink it, maybe try to get some sponsorship, that sort of stuff. So the Ag Day organizers, and I'm going to run out of room here, but they may need to consider sponsorship. How do I spell sponsorship? Forgive me, I'm not the best speller or writer. So sponsorship, or they may need to consider a redesign. So something a bit smaller. Or maybe there's some existing shade they can use kind of within the school. So all of that combined is how we're going to get the excellence mark. But it is important. We've got the sketch, so make sure you're doing that. Following that, we calculated the height of that shade triangle. And I think that's where the merit mark kind of locks you in. Following that, we then estimated or calculated the area of the shade, then its cost, and then after that we related it back to the scenario, and we extended our thinking a little bit by chatting about this Ag Day sponsorship and redesign of the shade. So that wraps up the right angle triangle practice task that we're looking at for the 11 math class. Hopefully you found it useful. Do ask me questions in the comments or in class or whatever if you have any.